This is going to be my advanced tutorial on MS41 tuning. This is going to build upon the basic and intermediate videos, so if you haven't watched those, if you want to go back and do those first, I would highly suggest it. The first one covers how to flash and read your ECU. The second one covers more in depth of each table in the ECU and what its functions are. And then this one is going to be actually logging data from the car and making changes based on the data that you've interpreted. So this is going to be for anybody that wants to make fueling changes, optimize their spark table, and even we're going to get into some Vanos tuning as well. I'll show you how to do that. This video is mainly for people that do sort of basic mods to their E36s or E34s, so M50 manifolds, M54 intake cams, adding M3 cams to your 328, gonna be air intake changes, deleting like the traction control module. You can replace that with an elbow. That's going to change airflow and fueling. Anytime you add headers, straight flowing exhaust, you're going to be making changes to fueling there. So I'll show you step by step the process of logging, making changes, logging again, and then making corrections to get things dialed in. I just want to note before we begin here, make sure your car is in working mechanical condition, okay? So you can't have any vacuum leaks, exhaust leaks, making sure that your fueling system is working, your injectors aren't leaky, your fuel filter's in good condition, fairly new, your fuel pump is working correctly, and make sure your Vanos unit is functioning properly. Your cam, crank, MAF, IAT sensors are all good. Throttle position sensor, like make sure everything's in top notch before you start logging, because if you start making changes against mechanical problems, that will just lead to even further issues. So make sure you have those addressed. Logging is actually a good way to identify what those exact issues are. Sometimes it takes a scanner or something and not just looking at a car physically to figure out a mechanical issue. So the logs that we're going to be creating are useful for troubleshooting as well. My general tuning process just coming into a car is I'll get my fuel table dialed in first, I'll move on to spark table, and then finally Vanos at the end. If you make some more drastic changes, you're going to have to change your idle tables as well. If you have really aggressive cams or something like that and it's not idling correctly, you'll be modifying those. So the main thing is we're actually going to be working in a sort of backwards process, okay? And what I mean by that is you're going to be looking at a table that you want to modify, right? So let's say you want to modify your fuel table. So you have to really look at your X and Y axis on that chart that you're trying to modify to figure out what parameters you need to log and what format those numbers need to be in, okay? So like for example, your fuel table is going to be logging or looking at your load axis and RPM. So you have to make sure that your load is in the correct unit, and then your RPMs set up exactly the same way it would be in the chart. So I'll show you that. So again, working backwards, if you know you need to modify a certain table, you need to set up those parameters beforehand before you even jump in the car and start capturing data. I mean, if you want to take one shot at it, you can definitely log all those parameters, but it does actually slow down the interface and you'll have a lower frequency polling rate if you start adding too many parameters in. The tools that you're gonna need, okay? So this cable is from my first video, so if you go ahead and watch that. This is just a cheap K-line cable. You can get them on eBay or Amazon for like 20 bucks. You do not need the round connector. So on US cars, if you have the cap in that round connector in the engine bay, if you have that closed, it will bridge the ports to make this available inside the car for logging for ODB2. I know for Euro cars, you actually have to do something a little bit different, and people have actually wired in ODB2 connectors in their Euro cars because they don't have these. So this guide right now is mainly for US people. There's another guy on YouTube, Pazzi. You've probably come across his videos. He does a more in-depth on the Euro cars and how to log, so if you want to check that out. The other thing you're going to need is the ROM Raider logger. What's nice about the ROM Raider logger, in addition to using ROM Raider to actually make the modifications, is all of your data is in the same units as both your tune and the numbers that you're logging. So there's no weird conversion or divide by 2 if you need to, take your data and move it into your tables that you need to modify. Okay, so it's a 1-for-1. Okay, whatever you're seeing being logged can transfer directly into your tune. So as long as you use that as your logging software. I know there's other ones out there like Testo and a couple other ones. So if you stick to ROM Raider logger, it'll work for you. The other thing is you're going to need to pony up $40 for the Megalog Viewer HD. Okay. This is mainly used for mega squirts, but this works great because the ROM Raider logger exports CSV files, and Megalog Viewer can import those, and you can graph, you can make plot charts. It's a really powerful tool and worth the $40. And if you're going to be tuning anyways, I mean, your cable was cheap, so might as well just buy some software since ROM Raider's free anyways. First thing we're going to do is just plug the cable into the laptop, and then we're going to open up our ROM Raider logger. And if you don't see this COM1 pop up, you're going to have to come into Device Manager. Go to Ports. And see where it says serial port and then the COM number. Just verify. You can come in to Properties, Port Settings, Advanced, and then you can actually change the COM port that's being used. So sometimes if you plug in a device and it's sharing the same COM port number, you can actually come in here and change that to a different one. So see on my computer it says in use, so just change it to a different one and then it'll become available in ROM Raider. Okay, the thing you need to do is come into select logging protocol options, and this you need to change to DS2 K-line. I think when you come in here, the default value is NCS K-line. I think this is for like Subarus or something. ODB won't work. It's going to be your DS2. The other thing is, if you have a wideband sensor, you can also plug that into your USB and then choose whatever one you have, and you can also log that channel as well. Once that's plugged in, you should be getting a message like this. As soon as you turn the key on though, okay, should be getting the correct values now. So you're going to get a parameter list here, okay? So what you want to do is make sure that most of these are fairly important, okay? So all the ones with stars, the star means that it won't slow down your connection if you log these specific parameters. These are considered high-speed parameters by the ECU, so you can choose as many as these as you want. So the one thing I don't have selected here and needs to be turned on is your lambda adaptation. So all the ones that I have checked here, and actually intake temp, I'm not sure what these heater values are for. I've never used those. Let's see, additive adaptation you want to turn on. Fuel injector pulse width is pretty important. And then if you need to mess with idle, you're gonna turn on your idle air control percent. So that's pretty much it for that. We got battery voltage. So you can see here, I have the dashboard pulled up. So you can actually see all the values being logged, which is kind of cool. And especially if you're driving the car and you're logging knock and you want to visually see if you have knock, you can see that here. Okay, so once you start the car and you start driving, you're gonna say start log file, and then you can give it a name. So I'll click this. Okay, you're gonna drive around. Let's say you need to, mess with your idle, so you'd have it idle for a couple minutes, or you'd make some wide open third gear pulls to check fueling, or if you want to, tune part throttle fueling or cruising, you would do that. And when you're all done, come in here and click save. Now the place that it's gonna save it is gonna be your, if you come in here, log file output location. So wherever you have that listed, it's gonna automatically save all your logs into that folder. The one thing to keep in mind here, so see these tabs at the bottom? So if you're running the dashboard, right, and you have these specific parameters being logged, they're not going to log. Okay, this is only for displaying values on the dashboard when you have dashboard selected. This little LTV, you press F6 or click on it, and yes, it's going to interrupt the logging. But this is going to pull up your adaptation tables, okay? So you can see here that my car over time has corrected 2% fuel, taken away 2% fuel. And then here you have your knock tables. So you have load at the top, like I was talking about, versus RPM. This is pretty important because you can see over time, and you can log this as well. But this is a overall saved on the ECU reading. But you could see at 3400 and at this amount of load, it pulled 1 degree of timing because of knock and 1 here. Okay, so we're gonna start with fuel tuning, okay? And this is not gonna be a tutorial on if you change injectors, how to scale injectors. This is gonna be for basically stock injectors. If you make any changes to any way that airflow is coming in, or change of essentially engine efficiency, I guess you could say. This is almost like a VE table if you come from other platforms. So essentially a more simplified version basically. So on the left-hand axis, you have engine RPM, and then this top axis, you have load, okay? Now load is a calculated figure. So if you look at this here, I'm looking at the MS41 wiki page. Load is essentially a calculation of airflow coming in from the mass airflow sensor divided by engine speed times this number. And this is their BMW's arbitrary engine load, okay? So this is saying how much air is coming into the motor times RPM to give you this load value. So we've seen this parameter in the ROM Raider logger, and it actually matches up exactly. Now, the other thing with fueling is these actual numbers in the table are injector pulse width in milliseconds. So this is how long per engine cycle your injector is staying open to squirt fuel. Now, if you make any changes to fuel pressure or anything like that, I mean, it's going to throw all of these numbers off because your basically fuel pressure is supposed to be at, I think, like 30 or 40 psi for an E36. So as long as that stays constant, the ECU knows how much to inject there. Now, the ECU also has a learning feature. These are called fuel trims. So if you've seen in the ROM Raider logger this lambda multiplication figure here, long-term fuel trim percent, it's a range from 8 to 12%, and it's going to be a multiplication of your base injector pulse width to get the car where it needs to be to run at 14.7 air fuel ratio, so perfect fuel ratio. So the ECU will do the best that it can and correct using these long-term fuel trim percentages on top of your base fuel table. So what we've logged, or should have logged for fueling, is going to be your engine load, your engine speed, and then your long-term fuel trim lambda percentages, okay? So just to reiterate, going back to our logs, we want to look at engine speed and load. We also want to take a look at injector pulse width to see if the ECU is commanding the same pulse width that we're seeing in the base map. And then we also want to see the lambda corrections that I've mentioned. So in Megalog Viewer, I have a quick log of my girlfriend's M3 that just did a quick pull to about, let's see, it's about 4,000 RPM. So when you open these files up, you can start logging your different parameters here. So again, the ones we want to look at right now are engine load, engine speed, fuel injector pulse width, and then your lambda corrections. Now, this log is a little bit inaccurate. So again, going back here, we want to actually look at this multiplication lambda, not the integrator. Integrator is your short-term corrections. We want to look at the long-term corrections. So just ignore this log for now. This should be the multiplication values, but it's the same process, okay? So let's take, for example, this line right here we have in the log. So we have a engine speed of almost 4,000 RPM. We have engine load of 500, okay? And then we're getting an injector pulse width of 8.6 milliseconds. So if we're going back to our actual table here, it's hitting the cell right about here. And my tune's actually different from the map that's in my girlfriend's car, a little bit different modifications. But essentially my car would be commanding 11 milliseconds and hers was commanding 8 milliseconds. So you can just do an initial check to verify that your ECU is doing what it's supposed to do first. Now the other interesting part is here you'll see that her ECU short-term, these are not the long-term fuel trims, but these are bank 1 and 2 O2 sensors. So these are correcting as much as 8 to 10%. Let me see here. And then towards idle, not too much. Now, these short terms are going to bounce around quite a bit, so this isn't the best representation. But anything over about 5% correction, you'll actually want to make a change in your fuel table. So let's say these were the long terms, and we were seeing a 10 and 14% correction here. You would want to go to this engine load cell and engine speed cell and your corresponding table and make that percentage correction. So here you would do, let's say it was 10%. So you would have to add 1.01 and then multiply. So that would add 10% fuel here in that cell. So that's generally how you would do it. I'll show you an even easier view and more powerful view you can have in this to just copy and paste your corrections and not have to go cell by cell to figure out where to make these changes. Another powerful feature of Megalog Viewer is this table generator. So actually what we can do is build a like-for-like table in our log, and on your y-axis you're going to have engine RPM, same values. We're going to copy those over. On your x-axis you're going to have your load, and then your z-axis, so the actual values in the table, are going to be your actual lambda % corrections. So all you would do is basically copy this entire table, come here and then paste. I think you can do, I'm pretty sure there's a way to do paste special and then percentage. I'll have to look into that, but let me just show you this real quick, how to set up the table. Your x-axis is going to be engine load. Your y-axis is going to be engine speed or RPM. And then your z-axis is going to be your lambdas. I'm pretty sure you can log the average of bank 1 and 2. That'll probably be a more accurate number, but I guess we'll just choose bank 1 for now. And then we just have to set up our axis next. Essentially, to set this up, all I did was I reset the rows and columns to match what we have in our fuel table. So 16 rows, 12 columns, exactly how we have it. Then I went ahead and changed all of the row and column axis, and I don't know if there's a way to copy this, but I did have to actually manually go ahead and type these all in. So if you double click, you can change each value. So now it actually matches 1 for 1 these table column axis. So once you have this all set up, you can actually save this histogram view. So this is only a one-time setup thing. But essentially what you get once you've logged engine load, engine speed, and your lambda is a correction factor of all of the cells that you've driven in and how much the ECU actually had to correct minus or plus percentage-wise to get your fueling to where it needs to be. So this is a very powerful view, and then what you can actually do with this is you can copy this whole axis over to this table and paste it in and by a multiplication value and actually correct your fuel table just based on your narrowband sensors, which is pretty cool. I know this takes a lot more time than an actual wideband, and once you add these in, you're gonna have to do a little bit of smoothing. So there are smoothing tools in here to change these, but essentially your log is gonna tell you how much you have to correct your fuel table or how much it's off. So when you do make those heavy modifications, so let's say cams or intake tract or exhaust, and then you start seeing correction factors more than like 5%, you can see that, for example, here, the ECU had to add 12% fuel. The ECU here had to take away 8 to 10% fueling from what it thought it had to do based on your original base map. Okay, so we've come to everyone's favorite part of the video, because this is actually how you make power. So after your fueling is dialed in, even if you don't make any changes and it's a stock fuel map and it's all good, you can actually make a decent amount of extra power and have a ton of drivability and responsiveness if you tune this ignition timing table. So when you order tunes from RK Tunes and all those guys, Castle Performance, the main thing they're doing is modifying this bass ignition timing and Vanos too, so we'll get to that as well. So the method that I do, since I don't have a dyno and street tuning, is I will keep increasing this entire table by, I'll start with probably 5 degrees from just a bass tune because BMW is fairly conservative with this. So across the board, I'll add like 5 degrees of timing. And if, I'll go and log knock. If I see knock, I'll come in and take, a little bit of timing out of the cells where the knock occurred. And I'll just keep doing that, keep increasing timing. But you'll get to a point where you'll add so much timing that the motor won't like it and you'll actually start not making as much power. So since we don't actually have a dyno, what you can do is using your load. Load is almost a good indication of how much power you're making. So not the best, not one for one, but at least you can see if load is increasing or decreasing with these timing changes. You're heading in the right direction. You're making more power. Other than using your butt dyno, you actually have physical numbers you can do and look at. So again, I would come in here, start off with adding 5 degrees. Again, your motor's only going to take so much, obviously, before it starts knocking, especially if you have crappy 91 octane fuel or less, depending on where you're at. So again, I'm going to come back in here and use the same powerful chart. So actually, the first thing I'm going to do here is clear this out. And clear out injector pulse width. And all I want to log here is ignition angle, knock retard current. I believe there is another ignition retard that has to do more with reducing timing if your motor is getting hot or your intake air temps are getting hot. The ECU will dial back the timing in those events. So that parameter has more to do with that. But if you want to tune and make sure your motor's safe, you're going to look at this knock retard current, okay? So as you're going through, this is just a idle tuning graph I have here, so nothing too crazy. Obviously, there's no knock on this one. Here, I've recreated a knock event, okay? So essentially, if you did have knock occur, you would see on your knock retard current that, it'll start at probably 1 or 2 degrees, work its way up to 7 to 10 degrees of knock retard, depending on your tune settings and what the DME wants to do, how severe the knock is. So you're going to look here, and you're just going to see this spike. The other thing you can do is come in here. Since the ignition table uses the same axes, it's pretty easy to change this to a knock occurrence table just by changing your z-axis here. Knock retard current. I don't think this is showing, it may be my decimal places, but essentially you can see at 900 RPM, at this engine load, we've seen a bit of knock. So again, you would come in here for this knock event, come back into your spark table, and then 900 RPM at this load, you would take a couple degrees of timing out in this area that you've seen the knock actually occur. I just realized for this chart, you actually have to change this in the table display options. Mine was set to weighted averages. You're going to actually set this to maximum values. So you could see here it was the ECU took out 7 degrees of timing in this knock event and 1 degree here. So as it ramped in and had a knock occur, again, this is where you would take that out in the same area. This is going to be quite a tedious process. As you go through and you keep adding timing in, you have a knock occur, you would go out again and drive and log the same parameters to make sure you don't have knock, and just kind of repeating the same process. Your quote-unquote dyno to actually see if you're making improvements or making things worse, because engines like that sort of sweet spot of timing, you can come in here and load engine RPM and load, and actually you can put these in the same table here. So you would go through and do a poll, and you would basically compare back to back, and I think you can load multiple tune files into this. I haven't really worked with this too much, but I know there's other programs where you can load in multiple tune files and do comparisons. I'm sure you can do that with this. But essentially, you'd want to compare back to back if you're hitting higher load cells at the same RPM. Now, again, you have to keep things consistent with that, because load versus speed, engine speed, isn't always indicative, because if you're going up a hill or downhill, so you'd have to have pretty flat, consistent ground and make the same pull in the same gear to really measure these things back to back. But this is your sort of pseudo street dyno, if you will, to actually see if you're making power improvements or not. Getting into Vanos tuning, this one's a little bit interesting. It works a lot better when you have a dyno available, but I'm going to show you how to do this with a, on a street tune. When you add in a M50 manifold, or even stock settings are fairly conservative with when it turns off the Vanos. Essentially, the general tuning process is you want to log load and RPM with Vanos disabled, and then do a wide open throttle run to the rev limiter. Same thing here. You want to do load and RPM with Vanos always enabled, and do a wide open throttle run to the rev limiter. Then essentially you're going to create an X and Y chart with RPM and load, and you're going to compare those two charts and see where those graphs cross. So in this example, these two curves intersect at 6,000 RPM. So this is the ideal point in which you want the Vanos to turn off in this scenario. And one thing with Vanos tuning is it takes around 200 to 300 RPM for the Vanos to fully make the switch. So this one, for example, it makes that intersection at 6,000 RPM. You want to do that around 200 to 300 RPM sooner than the 600 point for it to switch over and build the proper power that it needs to. I don't have the actual full version of Megalog Viewer on this PC. I have it on my tuning laptop, so I'm unable to open that second file to do the comparison run. But essentially what you're looking at is, again, that intersection between where your two loads will overlap, and that's where you want to turn off that Vanos. You would come into your actual tune here, go to Vanos, and then go to your heavy throttle on and off. So again, here is your switch point. Now this is also factoring in vehicle speed, so you're gonna want to make sure that's logged as well. I think that's gonna be it for today's video. I'm actually gonna make a additional fourth video on forced induction tuning. So that's actually going to be involving scaling the mass airflow sensor to double the limit of what the ECU can read, because the stock ECU is only a 1,000 kilogram per hour load. So you would actually double that for force induction to get past that. We're also going to be getting into injector scaling. There's some spreadsheets to actually scale those. We're going to be getting into how to run different mass airflow sensors. So a lot of people will use the stock MAF with a resistor inline, or a Nissan slot MAF to be able to have higher limits for boosted cars. So I'll be making a video on that next. I have to do a little bit of research on a couple things, but I'm pretty confident I can make that one. So stay tuned. Thanks, guys.